All right, in this video, we're going to go through and talk about the second two properties of logarithms and manipulating logarithms and working with them before we get to actual equations involving logarithms. So whenever you have, and again, you guys might already have some stuff written here. Those formulas are great to have here, but if you want these examples, you can also write them in here or off to the side. So if you have an exponent inside of a logarithm, and the inside part is a little tricky for this one, and I'll show you what I mean. What you can do is that can transform. So let's do log. We'll do a common log. So log with no base, quote end quote, which just means it has a base of 10. Let's do r to the third power. Basically, so this is an exponent inside of a logarithm, right? It's got log of r cubed, that exponent's down there. You could also rewrite it as log of r cubed like this. And so this one makes it look like it's not necessarily inside of your exponent, or inside of your logarithm, excuse me, but it is, right? It's still on that r, and that r is in your logarithm. So again, I prefer to write it with the parentheses just to make it clear, but questions could have it without that in there as well. So log of r to the third power, that exponent can in fact change and expand our logarithms. Log of r to the third would be 3 times log of r instead. This exponent can come down and multiply in front, and now we've expanded it into more logarithms. Technically, I have 3 logs now of r. Instead of just log of r to the third. So if you want to expand your logarithms, that means that now there are 3 of them, right? So I can bring down that exponent and multiply it in the front. The same thing would work if I wanted to start condensing my logarithms. If I wanted to move this 3, and I can make it back up to an exponent on here. All right, so that's your exponent inside of a log rule. The other thing that you have to be able to do is the change of base formula, and especially if you're not feeling particularly handy with your graphing calculator, the change of base formula basically allows you to calculate any logarithm. So you've noticed that I've sometimes put numbers in my logs and sometimes I put variables. So anytime that you're doing the log of a number, and you want to actually calculate logarithm of that number, you can use this formula. So if I had log of, let's put a little 5 or something down there, and then we'll do, I don't know, 34. Sure. So log base 5 of 34, if I actually wanted to calculate that, you can get to this sort of logarithm in like some sub menus in your graphing calculator, and if you're really interested, I can show you how to do that. But you can also always use your change of base formula, which says if I have log base 5 of a number, my calculator doesn't do that very easily. The only ones it does normally are regular log and then natural log. So my common log it'll do really easily. It'll do my natural log really easily. I could instead rewrite this with my common log. So log of 34 divided by log of 5. So you take log of whatever you're taking the logarithm of and divide it by log of 5, and you would get the correct answer. It would also work if you use natural log in this scenario. So natural log of 34 divided by natural log of 5. And I tend to use natural log more just because natural log occurs a lot with ease and such, and logarithms, regular common logs, only work with regular numbers. So, oops, sorry. So on your calculator, your natural log button is directly next to your 4. So if you look at your 4, right next to it is natural log, or if you want to use common log, that's right next to your 7 button. So if I type into my calculator natural log of 4, close those parentheses, 34, close those parentheses, divided by natural log of 5, I would end up with 2.191. And so I've accurately calculated the log base 5 of 34. And again, like I said, it will work with common log if you did it that way too. If you typed a common log of 34 and parentheses divided by common log of 5, you get exactly the same number. So, and it will work for numbers where they're not necessarily larger and smaller, so it would work. So let's say I wanted to calculate log base 26 of the number 2, for example. This number is much larger, but I could still calculate it using log of, oops, let's write it up here, log of 2 divided by log of 26. It's always what you're taking the logarithm of goes in top, and then the base goes in the bottom. So it doesn't matter which number is bigger and which number is smaller, just your base part would always go in the denominator. All right, so that is your change of base formula, so calculating any logarithm with numbers in it, and then your exponents, bringing down your exponents to multiply in the front of a logarithm.